Now the problem based on first shifting theorem in inverse Laplace transform. Now let me take the one problem. Find inverse Laplace transform of first bit s plus 2 by s square minus 2s plus 5. First of all, you should consider the denominator part. Actually s square minus 2s plus 5 is there. The upper part is, numerator part is s plus 2. Then L inverse of s plus 2 by s square minus 2s plus 5. This s square minus 2s is available, means you can write s minus 1 whole square in the form of, according to middle term you should write like that. S square minus 2s plus 5, that can be written as s minus 1 whole square plus 4. Already I did here at first. S square minus 2s plus 5 equal to s minus 1 whole square plus 4. L inverse of s minus 1 plus 3, this s plus 2 can be written as s minus 1 plus 3. Here s minus 1 whole square plus 4. Why should I write s plus 2 can be written as s minus 1 plus 3? Why should I write like this? Means s minus 1 plus 3. Means the denominator part s minus 1, it is containing s minus 1. The numerator also you should convert in terms of s minus 1. Then only we can apply first shifting theorem. Then this can be divided into small terms. S minus 1 by s minus 1 whole square plus 4 plus 3 by s minus 1 whole square plus 4. By first shifting theorem, s minus 1 is there everywhere. S minus 1 is e power t. L inverse of s by s square plus 4 plus 3 by s square plus 4. Then e power t into L inverse of s by s square plus 2 square plus 3 into L inverse of 1 by s square plus 2 square. This can be written as e power t from the basic formulas, e power t into cos 2t plus 3 by 2 into sin 2t. This is the, like this we can solve the problem by using first shifting theorem. Now one more problem. Find L inverse of s plus 3 by s square minus 10s plus 29. Now observe this one. The question, once again I am writing here, L inverse of s plus 3 by s square minus 10s plus 29. The middle term is minus 10 is available. That's why I want to write 2ab. Means 2ab is nothing but 10s is available. 2 means 5s. This can be written as 2 is 2 and the remaining, if you want to get 10s means 5s. That's why this can be written as s minus 5 whole square. S minus 5 whole square means s square minus 10s plus 25, but the constant is 29 is available. Then how much I have to add? 4. That 4 can be written as 2 square. The first one is s plus 3. The numerator is s plus 3. Now here s minus 5 is there. Numerator also you can write in the form of s minus 5. L inverse of s minus 5 plus 8. To balance the numerator, you have to write here 8. Then once again L inverse of s minus 5 plus 8 by s minus 5 whole square plus 2 square. Then split it. E power 5t L inverse of s plus 8 by s square plus 2 square by shifting first shifting theorem. E power 5t L inverse of s by s square plus 2 square 8 into L inverse of 1 by s square plus 2 square. The answer is e power 5t. From the basic formula, this is cos 2t and this is nothing but 8 into 1 by 2 sin 2t. Then from the basic formulas already I explained you, the final answer is e power 5t cos 2t plus 4 sin 2t.